So we're going to be looking at inverse trig ratios, and we're going to I don't know how much experience you have with this word inverse yet. You definitely have seen inverse operations. So like, what's the inverse operation of addition? Subtraction. And the idea of inverse is to undo what you did. Like, if I start with the number 5 and I add 10 to it, I'm now at 15. Well, if I want to get back to 5, I need to undo what I did, so I subtract what I added, and I get back there. Or if I multiply something to 5, like I multiply 5 by 4, and I go from 5 to 20, and I want to go back, what's the inverse of multiplication? Division, right? So you've seen things like inverse operations. You don't really probably have much experience with inverse functions, and so I'm going to introduce an inverse function to you. We talked about on our, just going over the homework, if we have a 30, 60, 90 right triangle, the one that we memorized had a hypotenuse of 1, because when the hypotenuse is a 1, the other side lengths represent the sine and cosine. And across from 30 was what? What number though? 1/2. A half goes across from 30. What goes across from 60? Root 3 over 2. Okay, so if I say, hey, what's the sine of 30 degrees? You're going to tell me 1/2. Okay, so what if we didn't know, and this is what you would type into your calculator. Right now, you'd know the angle. You'd say, okay, I know the angle. Sine of that angle gives me that side length. What if you knew the side length, but you didn't know the angle, right? So say I was like, okay, well, sine of what angle is going to give me that side length, right? And so it's kind of, we need to undo what we did. So if I type in sine of 30, I get 1/2. Well, what do I type? How do I go backwards and get that 30 back, right? That's the idea, and that's your inverse stuff. So it looks a little funny, but the inverse of sine is written sine with a little -1. So it's not the sine, it's the inverse of sine. It does the opposite of what sine does, and you actually feed it a side length. So if you type that in, that will kick out an angle for you. And on your calculator, every calculator is a little different, but most calculators have a sine button. And above that, you'll see a sign with a little -1, the inverse sign. And that's what you want to access. In order to access that inverse sign, usually there's like on the top left hand, there's a second key or a shift key over here that you're going to have to hit first. And so you'd hit the second or the shift, and then you hit the sign button, and then up comes your inverse sign. And you could try that. If you can access it, try the inverse sign of 1/2, and it should give you 30. Okay. It wasn't okay. So that's the new part. And cosine has an inverse, tangent has an inverse, and what you just need to remember is the only time you need these things is when you're looking for angles. So you don't use them; they don't come up a lot. But when you're looking for an angle, that's when you're going to need it. Okay. So let's take a look at number 1. We're going to start the same way we did yesterday. We're going to draw a triangle similar to the one we're looking at. We're going to scale it down to have a hypotenuse of 1, so we can talk about sine and cosine. The angle x is what we're after, and because these triangles are similar, this also has the same angle measurements, so I could put angle x in here, which the side length across from that is going to be the sine of angle x, and the adjacent side is going to be the cosine of angle x. Okay. And if you're having trouble knowing, like, where do I put the cosine, you could do the order I do. You find the hypotenuse first, and then you find the opposite side. That's your sine, and then the leftover sine is cosine. Another way that people like to think about it is When you're looking at an angle, here we're looking at angle x, that angle is made up of two of the sides of the triangle. One will always be your hypotenuse, the other one will always be the cosine. So those are the hypotenuse and the cosine are always the two sides that make the angle that you're looking at. Okay, so if that helps you, you can use that. So 24 and 15 is what is given to us, and they correspond to 1 and sine. So can somebody give me a proportion that's true here? What did you say? 24? 24 over 15 is 1 over sine x. Perfect. And that works good, and you can cross multiply at that point. So 24 times sine of x is equal to 15. And then divide by 24, and you get the sine of some angle x is equal to 15 over 24. And so you can see this is kind of the inverse situation, because normally we know the angle, and we would plug the angle in, and we'd get 15 over 24. But we know 15 over 24, we want to go back to the angle. So this is when we're going to need the inverse sine. So you write sine with a little -1 here, and I know it looks like to the -1 power, but it's not. It just represents the inverse at 15 over 24. Okay. So if you don't have a calculator with you, this is as far as you can go right now, and this is where you would stop. If you did bring a calculator with you, then you're going to want to type that in and estimate it. And the reason I'm encouraging you guys to get the calculator as soon as you can and bring it with you is because every calculator is a little different, and there's some get to know you time with that calculator. Because what you don't want is that test day comes and you scrounge and you get a calculator and you don't know how to use it. And you have these problems, like you know how to do it mathematically, but you don't know how to type it in. Or maybe you think you know how you're typing it in, but you're getting the wrong answers. You don't want that to happen on test day. So that's why if you bring it early and start working with it, get to know your calculator, much better thing for you. Okay. So what are we getting here? So inverse sine 15 over 24, 38.7 rounded to the nearest 10th. Correct. And we're talking degrees here. Okay. So it's a lot like what we were doing before. The beginning is really much the same, setting up a proportion, using the triangle with a hypotenuse of 1. It's just that last step, the inverse function. Let's look at number 2. So I'm going to draw a smaller version, scaled down version with a hypotenuse of 1. These triangles are similar to each other, so they have the same exact angle measurements. So I'm going to put x in here. Across from angle x, when your hypotenuse is 1, that would be the sine of that angle. And then the leftover is the cosine of that angle. And we're working with 11 and 8, and they correspond with 1 and cosine. And so we set up a proportion. Now, I don't know if at number 1, we could have set up the proportion in a way that would have cut at least 2 steps down. So it's not wrong. It's not too much work. It's fine. But if you're like, hey, I'd rather have less work, there's a way to set up these proportions where you have less work. Because when you set up a proportion, there's probably 4 different true proportions you can set up. And one of them's going to really be nice in this scenario. Anybody see the one that's going to be nice? Yeah. If I go cosine of x over 1 is 8 over 11, I don't need to cross multiply now because it's already solved for cosine x. Right? Because that over 1 is itself. And so that my next step would just be, well, then x is the inverse cosine of 8 over 11. And now it's already calculator time. Okay. So if you don't catch that, that's fine. You just have a couple more steps to do. If you see that, you might as well do that, right? And you should get 43.3 degrees. If you're not getting that, you're trying it on your calculator, that's when you're going to definitely want to ask me or somebody around you and get that result. Okay, so get to know your calculator time. So I want you to try 3 and 4. And if you are having issues with the calculator or understanding this, that's a great time to ask. So here are answers for 3 and 4. You can check yourself with. Number 3, when you set up the smaller triangle, you see that 20 and 37 correspond with sine and cosine. And when you get that correspondence, think tangent, because you got sine and cosine. So this is where it also really matters what proportion you set up. You want to get ready for a tangent by setting up sine over cosine, and then change it to tangent, and then use the inverse tangent with the 28.4. Number 4, when you set that up, you see that cosine is the thing to use, and it works out nicely. Question on that one? Okay. Then we're going to stop there.